Here is another example where we'll try to find area of a triangle using Pythagorean theorem. Question is, find possible areas of an isosceles triangle ABC with AB equals to 5 centimeter and AC equals to 6 centimeter. I'd like you to read the question again and understand what we're trying to find. It says find possible areas. That means there's a possibility of more than one area. Now, how is that possible? We are considering isosceles triangle ABC with two given sides. Let me make one. So let's say this is one of our triangles, right? ABC. Let me write down ABC here. Say the sides are A, B, and C. It's given AB is 5 centimeters, so that is 5 centimeter, and AC is 6 centimeters, so this is 6 centimeter. Now, since this is an isosceles triangle, two of the sides should be equal. Now, what is CB? Well, CB could be 5 centimeter or 6 centimeter. So that gives us two possible triangles and therefore two possible areas. I hope you appreciate it. So, in this one, let us say side CB is 6 centimeter. And then we need to figure out the area of this triangle, right? Now, let me draw another triangle. In that, I will take this side to be 5 centimeters. So, let's say that is this triangle. And this is our triangle ABC. We're given 6 centimeter AC, 5 centimeter AB, and now we are considering CB as 5 centimeter, right? So this is a smaller triangle. We should expect a smaller area in this case, since the two sides, equal sides, are 5, not 6, right? Let's figure out area of these triangles. To find area, let's draw a perpendicular from C in this case to the base AB. Now, why did we select C? The idea is, since it is an isosceles triangle, perpendicular will divide AB into two equal sides, right? So let's say if D is the point which makes perpendicular from C to AB, in that case, AD and DB will be equal, right? So if they are equal, then AD is going to be 2.5 and therefore DB is also 2.5. Now, as you can see, triangle CDB is a right triangle and we can find the height of the triangle. We need to know height and base to find area of a triangle, correct? So that is how it helps. So area of the triangle, let's say triangle given to us is half base times height. Now base is known to us, which is 5 centimeter. What is the height? To find height, let's say h, we use Pythagorean theorem. That is how it comes into picture. So height is equals to, it is smaller than the hypotenuse, that's the right triangle. So difference of squares, which is 6 square minus 2.5 square, square root, right? That is the height. So let's figure it out, how much it is using calculator. 6 square minus 2.5 square, and then we'll do square root of this, which is equal to 5.454. Now area of this triangle, let's say area of triangle, let's say 1. So area of triangle 1 equals to half times base is 5, let me write it in brackets, times height of 5.454. So when we multiply all this, so divide by 2, we get our answer as 13.635, which I can write as 13.64 approximately. Units are centimeter square. So that is how we can find one of the areas of the triangle. Now for the other triangle, we should draw perpendicular from B, since the two equal sides are 5 and 5. So when you draw perpendicular from B, it will be connected with the center of this triangle, right? So that is how it is going to be. And let's say this point is O for us. Then AO and OC are going to be equal. They will be half of 6, which is 3. So in this case, just as we did in the previous case, we can find height of this triangle. Let's say this is h. So height in this case will be equals to square root of hypotenuse, which is 5. So it's 5 square minus 3 square, square root. So 3 is 3, 4, and 5 triangle, right? So which gives us height of square root of 16, and that is 4. Now we know the height, and therefore area of this triangle is equals to, let's say triangle 2 is half base of 5, right, times height of 4. Sorry, the base is 6, not 5. That becomes the base, AC. So base is 6 for you, and height is h, which is equals to 4. So that gives you a value. 6 divided by 2 is 3. 3 times 4 is 12. So it is 12 centimeters square. So as you can see, we have two different triangles, and as expected, the one isosceles triangle where two sides are 5 centimeters has a smaller area of around 12 centimeters squared, and the other one has a slightly bigger area of 13.64 centimeters square. I hope you appreciate that there is a possibility sometimes with given conditions that you can have two different triangles and therefore two different areas. I hope that helps. Thank you and all the best.